Hello everyone, welcome to Cookroid. My name is Saurabh Kukreja, and today we'll be doing day 25 challenge, in which we'll be talking about runtime and complexity of our program, of our algorithms. So in this, we are talking about checking whether the number is prime or not, and the way we check it is if the number is divisible by any other number than itself and 1, it is not prime number. Example, 6, it's divisible by 1, 2, 3, and 6 itself, so that is not prime. Whereas if you consider 13, it is a prime number because it's not divisible by any other number than 1 and 13 itself. So what we have to do is, in this we can obviously check for all the numbers from 1 to n. If it's divisible by any number, then we say that it's a prime number, or else we don't say it's prime number. So for that, the complexity will be n, o of n. Why? Because we have to check n times whether the number is prime or not, right? But over here, because the program problem statement is to check runtime and complexity, and they are saying that it's possible to try to come up with O log n time complexity for this. So let's see how we can do that. I've already added some code over here which accepts the inputs and stuff, and I have a method which tells whether the number is prime or not based on this. So let's go ahead and write this method. So our first condition will be if the number is 1. So 1 is neither prime nor false, so we'll return false. It's given in that statement, so this is pretty simple. We'll simply return false. Then second, what we have to do is we have to loop until that number to see if it is divided by any other integer or not. So what we'll do is while we need to take a while loop, so we need to increment a counter. So for that, I'll take I equals 2. Reason, because it is we know that integer will be divisible by 1, and we should start ideally from 2, so that's why I'm starting from 2. And I'll say if I is less than n to begin with. I'll change that later. If it's less than n, and if num, this should be num, and if num modulus I equal 0, that means it is exactly divided by that integer I, and then we return false, or else we'll increment I, and then if we come out of this return of this for loop, that means we have not returned anything. That means our number is prime, so we'll simply return true. But in this case, as I mentioned, like we are running the while loop n number of times, we don't want to do that. So what we can simply do is, because we know that any number which is the last maximum divisor of that number will be its half, at least its half. So we'll just say should be less than num by 2 or equal to num by 2. Example, if we consider 12, the last integer that it is divisible by is 6. So it's not divisible by 7, 8, 9 or any other number, right? So that's why we will just loop until num of 2, and that's the way we are increasing or improving our efficiency of the program. Now let's try to run it and see if this works fine, any compile time issues or anything. Yep, this is fine. And if you will see, there are a couple of test cases, like let's say this one, this is taking too long to build up. That's how they are checking the time complexity they were taking. So let's just say if we run until num, what will happen in this case? These two cases are running for a long time. Should be this actually. So if you see over here, your code did not execute within the time limits. That's what they're looking for. So that's why we have num divide by 2, so that our codes run with the time of O log n. That's about time complexity. Thank you so much for tuning in. Let me know if you have any comments or questions. Stay tuned for day 26 challenge, guys. Thank you.